How you guys doing today? This is that sheet I gave you, worksheet 4-3 on the trends. And the first one is talking about the radius. And number one would be it gets larger. And the reason is because you have additional energy levels as you move down the group. So if we look at the table and you're looking at CA here versus BA, this CA has 4 energy levels, the BA has 6. So this BA is way larger. Okay, let's look at number 3. Now what we're talking about as we go across the table, left to right, you're going to decrease in size or get smaller, and that's because of the fact that you have more electrons pulling inward on your atom on this side and less on this side. So as you move left to right, it gets smaller. All right, now number 5, where they want you to tell you which one's larger. 5A is going to be aluminum, and that's because you have one more extra orbital. B, S versus O. S is larger because of the orbital concept again. And letter C, again, we go back to the orbital concept, BR over CL, a little bit bigger. Now you got NA and AL, which are in the same period. NA's got 11 pulling on 11. AL's got 13 pulling on 13, so actually the NA's bigger. O and F, same thing, same period. O's got 8 pulling on 8. F has 9 pulling on 9, so O is bigger. And then F, your CA is bigger because they're in the same group. And CA has 4 and MG has 3. So CA is bigger. All right, now we're moving down here to ionization energy. And what's the definition? It's the energy needed to remove one valence electron. So when you see VE, that's a valence electron for me. Is it easier to form a positive ion with an element that has high or low? And that's going to be low because lower energy equals easier to remove. And I put here example, francium would be really low, Li much higher. Okay, what's this one say? Oh, larger one, Na versus Mg positive 2. Here's the math here. 11 pulling on 10, 12 pulling on 10. This one has 2 extra protons, so it's smaller. The Na is bigger. 9. This is a pretty easy question because obviously those electrons are closer to the nucleus. And yes, that's my dog barking in the background. Sodium forms a positive 1. Magnesium forms a positive 2. And I show you here, sodium loses 1 valence for +1. Mg loses 2, +2. And they both end up looking like neon. And then 10, the trend as you go down the group is you're getting lower energy because your outer valences are getting further from the nucleus, which obviously attracts the negatives.